Okay, now we learned how to count atoms. We're going to learn about Lewis dot structures of a single element. Let's review. On the periodic table, how do we figure out how many valence electrons an atom has? And remember, a valence electron is the electrons in the outermost energy level. So when we draw that atom, we're talking about that last ring. How many electrons are in there? So for example, hydrogen, lithium, sodium, those are in group 1, so they have 1 valence electron. Beryllium, magnesium, calcium, they're in group 2, they have 2 valence electrons. If we come over here to boron, aluminum, gallium, they're in group 13, they have 3 valence electrons. Carbon, silicon, germanium, they're in group 14, they have 4. So how can you find the number of valence electrons an atom has? It is the last number of the group number. So remember, group 14 has 4, group 18 has 8, group 6 has 6, group 2 has 2. So the first thing we're going to do to draw a Lewis dot structure is to draw the element symbol. So if we're going to draw the Lewis dot structure for chlorine, we're going to write chlorine's element symbol, Cl. Next, we want to look up the number of valence electrons that atom has. So for chlorine, it's in group 17. So remember, that's the last number. It has 7. The valence electrons are going to be represented by dots on the structure. You're going to place 1 valence electron on each side of the symbol, as if there was a box around the symbol. So you're just going to pretend like there's 4 sides to that symbol, a top, a bottom, a left, and a right. Once there is a valence electron on each side of the symbol, you're going to go ahead and pair up the remaining valence electrons. So let's go ahead and try to draw this symbol. So let's try chlorine one more time. So we have the element symbol for chlorine, Cl. We went ahead and looked up the valence electrons on the periodic table. Remember, that was 7 because it's in group 17. So we have 7 dots to put on the structure. We're going to put 1 dot on each side of the symbol. So 1 on the left, 1 on the bottom, 1 on the right, and 1 on the top. Now we have 7 total to put on here. We have 4, so we have 3 more to put on here. So we're going to pair up 3, 5, 6, and 7. So the whole point of a Lewis dot structure is to show the electrons that currently have partners, have pairs, and show the ones that do not. We call them lone pairs, or ones that are looking for a partner. So notice chlorine has 1 electron that's all by itself. So chlorine is going to want to react with something to give it 1 more electron. So go ahead and try sodium now on your own. So the first thing you should do is go ahead and look sodium up on the periodic table, and you would find that it's in group 1. So you would have 1 valence electron. So you would be putting 1 dot on this diagram, and that dot can go on any side. Now go ahead and try nitrogen. Okay, you should look nitrogen up on the periodic table and find that it's in group 15. So that would be 5 valence electrons. So you would want to put 1 on each side. And then pair 1 up, and it doesn't matter what side. Go ahead and try carbon. Okay, you should have looked carbon up on the periodic table, and it is in group 14, so that is 4 valence electrons. So that is 4 dots, and you need to have 1 on each side. And it doesn't matter where you start, but it does matter that none of them have partners. Let's finally try magnesium. Okay, should have looked magnesium up on the periodic table, and that is in group 2. So it has 2 valence electrons, so that would be 2 dots, and they can go on any side.